Hello, Matt. Can you hear me? I'm talking. Does it sound pretty good? All right. Actually, I guess I'll probably be a little louder than this. I'm talking to them, so if you... Well, welcome. Who's excited?
Yeah.
Really? All right. I wasn't this morning, I won't lie. Not about the class, just semester starting. My name is Adam Beehler. I should write that up. You'll see it on the website. That way you know who I am. And this is Physics 1010. 1010, so if that doesn't sound right, you can leave now. Or stay, I don't care. All right. How many are looking forward? And I want an honest answer. It's the beginning, you don't know me yet, I don't know you, but you don't have to butter me up. Who likes science? Hey, more than I anticipated would fess up. All right. Who loathes science? Is that a sort of? No? Well, that's good. Hey, they usually have at least one. This is good news. I realize most of you aren't non-science majors, and you probably have to take this class because it's required, but other than that, it's okay. Physics 1010, the way things work, it's a conceptual physics class, and most of what I want to tell you is just in the syllabus, so warned you now, I'm going to go over it, mainly because not to bore you and it's logistics. I know you're old enough to go read it yourselves, but most of the main points I want to get across to you, I put in the syllabus, so I'm just going to go over it. So this will be an easy lecture. Well, that'll take up the first part, and then we'll get into chapter 1, which is about science. And I'll explain the book as we go through it. Before I do that, I'm going to pop it up there so we can follow along, but you guys might as well have a copy. So here's a copy, and here's a copy. You can have the madhouse now and come down and grab one. See, messed up already, Catherine. I forgot to turn on that. And Matt, throughout this whole semester, really, if you think it'd be better if I redid something or you want a break, I'm flexible. Just let me know. All right. I was one of those students that the biggest thing I did not like about college was that I never felt caught up. I'm one of them that likes closure. I'll admit I'm organized. And in high school, I could go home, do my homework, and I was done, at least till the next day. Felt good. And in college, you know, they give everything to you. And you know everything you're supposed to be doing, and you'll never be caught up because there's always something. That's what I hated most about college. Thus, the first day of classes, I dreaded because the teachers would tell you all that. They'd give you the syllabus and you could see all that stuff, and from then on I felt overwhelmed. So I just apologize. That's the way college is, and that's what you get to do today. You know, everything I'm going to tell you is, oh great, more stuff to do. But I'm with you. Feel your pain. I'll just comfort you to know that any homework assignment or something, I'll give you plenty of time. You don't have to freak out. We're on no deadline in this class. We can go at the pace I decide. I mean, I don't have to regiment it like a lot of classes. So there's the info. Anybody here not registered for this class that's trying to? I mean, there's obviously room, so it looks like you can get, okay, that covers that. Excuse me. Sorry. There's my email. It's on there. You can email me, whatever. And the phone number. Office hours. It's to be announced at this point, mainly because I'm not avoiding you. It's more because I don't know what my schedule is yet. I help with every other lecture class doing demonstrations, and they haven't quite figured out their routine yet, so I don't really know when I'm free. That being said, I live behind this wall, right in there. You can get to it out there, and another door. I have 5 entrances. My name's on the door. There's doorbells. You can come by anytime you want. Call me, email me. We'll set up a time. We'll work out a time for you to meet with me. We'll always work out a time, even if you can't make my office hours, or I don't have any at the moment. I want you to feel comfortable with that. Because if I was a student, that'd work better, because then you can meet when you're free. TA, he'll be helping me with some of the grading. So if you have questions about that, his info's there for you. And the book looks like this. That little picture. But anybody have not gotten the book yet? Quite a few. So when you go there and you can't find everything, it looks like this. So you know you got the right one. I really like this book. I really like this author. I've known of him for a long time. I've actually used this stuff for a long time. This is the first time I actually get to teach with this text, so I'm excited. I did write on there. I chose this text because I really like it, but I really think you guys are going to like it. The way he explains things is more our style. I don't think of myself as a stuffy physicist. I mean, you might think I'm more nerdy and geeky than you are, but that's okay. I'm comfortable with that. But I try to explain it on a public level, not a scientist level, even though it's scientist words, so it might sound like it sometimes. So anyway, this is a great book, and I'm going to depend on it heavily. We won't cover all of it. It's got first semester and second semester physics in there, so we can't get to everything, so it'll be half or slightly less probably. What's next? I put a few online resources for you, a link to the Department of Physics webpage if you don't know how to find it. Webassign, that's how we're going to do homework. Let's do it now. You click on that link. If you just Google Webassign, you get it nationally, and you enter the institution Utah, and it just makes you log in again. So the Webassign Utah looks like this. Has anybody used Webassign here before? Several of you. I noticed on the roster many of you are freshmen or sophomore, about half, so maybe you haven't yet, but you probably will. It's basically online homework and grading. That's where I intend most of your homeworks to be. That way you can do it and turn it in this way. It's clean. We can read it. You can, it's 11:30 and you can meet in the deadline. You can finish it up at home at your convenience. You're missing the class when it's due. You don't have to be here and hand it to me. You can just plug it in. This is the login page. You would just hit login, and it uses, I'm already logged in, that's why. You don't need that then. You put your UID number and the same password. You guys are already, if you've enrolled in the class, you can access this. What I want to show you is the first time you get there, it'll look like this, and it says, according to our records, you have not redeemed an access code. You have a certain amount of time to continue your trial period, so you can get in there and check it out, make sure it works, and see the first assignment and whatnot. But eventually you will have to pay for this. It came with the, well, yes, bottom line. So that's what you care about. I think it was about 25. Do you remember? Well, it's well worth it. That way we can do everything centrally. That's what we're using. So when you first go in, just do the continue my trial period, and you'll be able to see what you need to see. It looks like this. So what I've at least started with, there's announcements over here, so if anything comes up or we change something, we talk in here and you didn't make class and something's important, I'll put announcements there. There's where you can click for the syllabus. That's what we were just looking at. I also have a resources where I can stick things, homework solution or testing solutions or whatever, links to other websites. And your assignments will be right here. And yes, you have one already. This is an easy one. You don't have to know any physics. You don't even have to know the correct answers. This is more to introduce you to Webassign. You can click on it and see it. Oh, let's do it. Tells you your homework, blah, 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 description. And it gets to the first question or so. And you can do this on your own time. You can print it out and work on it. You can answer it, but not submit it. So I suggest don't submit until you're done, you know. You can save your progress and come back. You're not trapped in it. The idea of this is a friend of mine made this up, and it's to get familiar with Webassign and the type of questions that can be asked. I don't expect you to know any of these answers, and I don't care. You're getting credit for taking the assignment, not for the correct answers. So play with it and get familiar with it. Like, for example, he usually uses this with the algebra and calculus-based physics classes, and they deal with scientific notation, so there's questions about that. I'm just telling you, don't stress over it. Enter an answer. See how it works. Let's see if it tells you if you're right or not. Doesn't matter. So that, I put a due date. I just forget what I put. I think I put Friday before class to encourage you to get in there and make sure Webassign's working and that you have access to it. And I'm babbling. Make sure it works. Because this week I'm going to post your first real homework assignment that will matter, doing problems from the book. And I want to make sure it's working for you. Any questions about this so far?
So when we start doing the actual assignments from the book, is it as soon as you submit it, that's your one chance, or is it?
Good question. Do you only get one submission? I get to set that up. It'll ask you, you answer a question. It says, do you want to submit for this question? You can right then, or you can just wait and answer all of them and then submit at the end. That's what I would do, because what if something down here gives you a clue to something up there? But say you hit submit for this one, or you submit the whole thing, and it tells you you're wrong. If I allowed you to have a second submission, then you can. It'll tell you. If I do, well, it'll usually be, if it's multiple choice, for example, and you get it incorrect, I intend to make the setting so it tells you you're wrong. You'll go, ah! You'll know right then. Try again. But if you get it right, you just won't get full credit. But you still get some credit right then. If they're written questions, I might give you multiple submissions without deducting, because say it didn't like how you wrote it, well, take another shot at it. I'd rather you learn and try to get it right than just move on. So most of the time you'll have multiple submissions. But you know, if it's yes, no, true, false, you get one shot. So make sure you're satisfied before you hit the submit button. Yeah?
So that the number of times that we can take a try depends on the assignment.
And even question, yeah. Yeah. You'll know as soon as you click. I would just default to, don't submit it until you really think. Don't depend on it. I intend to at least give 2. I'm still learning it myself for even the multiple choice. But yeah, the second one, you just knock some points. Yes?
So you said that we have our first real assignment this
Yeah.
So, my book is permanent.
Won't matter because it's on here.
Okay, so,
I can grab questions from the book digitally and put them on here. So you won't need the book to answer the homework. The book will just help you understand what I'm babbling about in lecture, right? Because we're talking about the same stuff. If you don't like how I say it, read it. Well, we're going to concur.
And it's due to midnight.
It says when they're due, each individual assignment. Yeah, this one I set up for Thursday at noon. Because I figured, I encourage you not to wait that long to make sure it works, because you'll probably want to start your homework that you haven't seen yet before then. But make sure Webassign's working and we got all the bugs worked out. I put instructor and student responsibilities. I'm aware that there's certain expectations on my end as well. You can read that. Cheating. I just want to say I don't tolerate it. I know everybody says you're not supposed to and all that. Well, I'm going to hold you to it, and you get 3 tries. If I catch you cheating, or I can tell you're cheating, I'll talk to you, and you could get a 0 on the assignment. Second time, I'll drop your grade, and the third time, I have the right to submit you to university where they could, I don't know, hold you back or kick you out. Don't cheat. If you're not sure if you're cheating, ask me. I'll tell you if you're cheating. Well, sometimes it's just confusing. Like, is this plagiarism? I don't know. I'll tell you. But you know, I see you copying off your neighbor during a test, well, that's obvious. Or bringing in cheat sheets or not allowed or something. If you need special attention, and you're uncomfortable talking to me, you can talk to the Office of, what do they call it? Americans with Disabilities Center for Disability Service, and there's a link there. So you can work out if you need extra time on a test, and they justify it for you, and then we'll work it out. No sense having to stress when we can help you. Course description, course content. Yeah, so what is this course about? That explains. This is not your typical physics class in that you're going to come and do lots of math problems. You will do math problems, but that's not my purpose. I want to teach you guys how to appreciate the world around you and how things work. You know, hence the title. It's conceptual. And so it's not so much you get a problem and, oh, what equation do I use so that I can figure out if I shoot it at this angle that far, it's going to land over here. I don't see most of you needing to do that in your life. Oh, I need it to land right there, so if I shoot it with this velocity, you can do that with physics and you'll get the stuff that you can, but that's not my focus. I would rather, if you increase the angle, will it go further or shorter? You know, if you're hanging like this versus like this, is there going to be more force over here or there? Not necessarily how much force, but this one will be larger than that one. Oh, the rope might break, you know, things like that. So you will have to think. You can't just plug and chug like some people get in a mindset. Oh, I don't understand physics at all, but I can answer the problems. So there's good and bad with that on you. Some of you are thinking, dang, but that's how it's set up. I love physics because as a kid, I would ask, how does that work? Why does that do that? Probably all of us have. I was the paranoid child, though, that wouldn't take things apart as a kid. Like, you know, a lot of scientists and engineers would take things apart, and their parents have those stories. Well, it was more important to me that the thing worked, so I was afraid to take it apart, that I couldn't get it back together. But once it broke, home free. Then, I would take it apart because I knew I couldn't make it worse. And actually, I know somebody in the class. Her brother helped me fix my dryer. It's a perfect example where, you know, this $100 appliance, and I can tell, I knew enough electronics that it was just one little thing. I knew it wasn't something big, and I didn't want to go spend $300. But I couldn't figure it out. I actually had the thing apart in my living room for about a year. It's another story. My wife didn't like me, but she had another dryer that was working. She was happy. Long story short, he came over and helped me figure it out. It wasn't the things I thought. We couldn't figure it out. I said, well, I know to at least clean contacts. So how do I clean contacts? Well, here I usually use acetone. Well, I didn't have any of that on hand. Well, but my wife's fingernail polish, that has acetone in it. Got it on a Q-tip, started rubbing around some things. Well, you know, my dryer's worked ever since. So if you know a few things about electronics, like, well, you got to make contact. There has to be a path for electricity to flow, and if something's blocking it, it can't work. So I just clean things off, and what do you know? It's still working. If you guys ever have questions about things out in the world, excuse me. Hey, I've always been curious, how does my microwave work? That's perfect for this class. Bring it up in class or ask me, email me, whatever. Curiosity is great. I don't know everything, but I can help us find out the answer, or at least what to do. Most of class time is going to be us discussing like this. I'll be explaining concepts and laws and principles. I actually talk more than I write on the board. Get me to do that. If I don't do it enough, tell me. Let me know. I'll write down the key points. And whatever I'm going to talk about is pretty much in the book, so you don't have to go crazy with notes, that's my point. And I use lots of demonstrations. My main job here at the university is demonstrations. Like I said, that's how I help every other class with demonstrations if the instructor wants them. And so that's what I like, seeing how the physics applies. And here's something, how does it work? Well, let's figure it out. So most days won't be like today. I had to at least pick a demo. It has nothing to do with what we're talking about, but I couldn't go to a lecture without a demo, so we got one. And we'll be doing that and discussing. I really want and encourage us to talk and participate. I know I like to sit in the back row and be a bump on the log. You can, I can't force you, but I really think you'll enjoy this class a lot more. And I'm going to encourage that, you know, when professors ask questions and they don't wait for answers, I'll make you uncomfortable until somebody answers. So, and with that, class participation. I have always wanted to use clickers, and this is the first chance I get to. We're going to have fun with those, and it's mainly so I can gauge your learning and be more effective and efficient. But I'm going to give you points for participating in class. It usually won't matter if you get the answer right or not. I want to know what you're thinking. We'll address the same question sometimes 3 times. Hopefully maybe you learn it by then, but I'll be able to see. So if you didn't notice when you bought your book, or buy your book, there's a clicker to buy. This is the university standard. So if another class uses this, you can use the same clicker. You don't have to buy another one, and you can sell this back at the end of the semester like a textbook, and you get the same, you know, non-100% refund as you do a textbook as well. But did you have a question?
Yeah, I got a clicker from my classes, but it looks a little bit different.
They have changed versions. I think the old version still works. Bring it and find out. Yes?
I don't know if this is true or not, but I heard that they're switching clickers because that's the one I have, and I got it last semester. I think they're upgrading or something.
They're always changing.
No, I don't think it works just fine.
They gave me this one right before break ended. So I was assuming it was a new one, but maybe they're already working on. Well, whatever the bookstore has, clearly that's going to work because that's what they're selling to you. So bring it, we'll find out. If it doesn't work, then we send it back and say, hey, give us the new one. And don't worry, I won't hold you to things and if you don't have a clicker because it's not your fault.
Will that work for multiple classes?
Yes, it will work for multiple classes. But it works through radio waves. There's a little dongle USB thing, receiver here. You guys all have them. The instructions, best of my understanding, is through WebCT, the online Blackboard learning, where you'd log in, you can see your classes there too. You activate this. You buy it and then you go activate it. When you activate it, then I can download the roster and see all you guys, put it in here, and then I know who's doing clickering. So, oh yes, she answered. Oh yes, he answered. Yeah?
What channel will be on the class?
I'll tell you. I think it's I don't know what it's currently set to. First, I'll look that up. We're not using them today anyway. I encourage you to get that this week though, because I intend to start using them Wednesday. I'll give you a grace period here for participation points. The way I want to do this is, I'm going to keep track of every time I ask a question, ask you to answer with this. If you do, and you answer all of them, you'll get 100% of the participation points. If you only answer 50% of the time, or you don't want to come to class, that's fine. You just will miss out on some these points. It's mostly so I can gauge how we're learning and teach you better. Homework we did. I'm not going to be worried that, well, yeah, I already explained all that. Tests. I intend to have, homework and tests, something you guys will like. I like it too, actually. You get to drop your lowest homework score. I would say do all of them, and if you bomb one, it won't count, I'll drop it. Or some people like it as an excuse to not turn one in at all. Fine, it won't affect you. That'll be your 0, it'll be your lowest score, obviously, we'll drop it. But what if you bomb another one then? Or you get sick? It's more for that, but it also means I don't have to deal with your late excuses. there's no makeup homework or late because that's the one, you can drop it. Same with a test. I'm going to try to have 4 tests so that you don't have just 2 and they count a whole lot more, but you get to drop your lowest test because I know some people just don't take tests well. It'll be roughly every 10 class lectures. That makes it nice and even. And we will have a final. I'll skip to here. It's already set. Put that in your calendar. I can't change it. That's the date. There's no makeup. That's what it is. It's here. It will be comprehensive, but I don't want to scare you. My intent is to not make those questions any harder than anything else you ever saw. I just want to see if you can. What do you retain? Here's how the grading breaks down before I get to the paper. I'm trying to make it because I hated the classes where if you bombed one thing, you failed the course. Well, here you can bomb any one thing and you can still pass. And the testing stuff is only half the points, and the other stuff's half the points. So you can, even if you did poorly on everything, you can still pass. Like to spread it out. I hate those final exams that were 50% of the points. Yeah. All right, to the superhero paper. There's another link in the resources on Webassign, but that's the back copy. You guys get to write a paper, which is unorthodox for a physics class 2. I don't care, because I think you guys are going to learn more writing that paper than you will in some of the homework. The best way for me, and when I was studying, to learn something was to try to explain it to somebody else. And so I'm going to have you do that. But you get to pick something, and hopefully something you enjoy, please do, and try to explain it to me. In theory, we've already gone over it, and you're going to have most of the semester to research it. You have plenty of time. This is due April. I have it there in your write-up. All the grimy details and instructions are there. Won't go over it in grimy detail right now because you haven't read it. But the gist is, design your own superhero. It's a short paper, 1 or 2 pages. Pick a superhero. Give him or her a power and figure out how he got it, the backstory. Does it use proper physics or not? Doesn't matter. You just have to justify. So you're going to learn all these physics concepts and principles. Put them to use. Make something up. Like, obvious, Superman, he can fly. Does that violate our current laws of physics? Well, it seems to, but can you justify it? Well, maybe if, that's fine. Maybe if's fine, as long as you can validate it. Maybe some of his powers obey physics and others don't. Maybe his power works because of physics. He's just smarter than everybody else, like Magneto in, help me out, X-Men. His magnetism there. A lot of those things could work if somebody knew how to do such things. But the physics mostly is true. That's cool. So I leave that to you. Read through it. If you got questions, ask me. We'll discuss it more later. Any now? Let me go to my classes, open student view, see what you guys will see. And it's right down here too, if you lose it, superhero paper in the resources. So you can print it back out. So yeah, that's one of those I tell you now, great, I got homework to do, but you can turn it in anytime you want up until that due date in April. I'm just giving myself a little under a month to read them all and get them back to you so you don't dump on me come finals. I think that's enough of the boring logistics stuff. Let's see. Okay. While I have this up, all right, I would like you to watch this short little video.
Here at Rockwell Automation's World Headquarters, research has been proceeding to develop a line of automation products that establish a new standard for quality, technological leadership, and operating excellence. With customer success as our primary focus, work has been proceeding on the crudely conceived idea of an instrument that would not only provide inverse reactive current for use in unilateral phase detractors, but would also be capable of automatically synchronizing cardinal gram meters. Such an instrument comprises of valve gears and bearings, reliant electric motors, Allen Bradley controls, and all monitored by Rockwell software is Rockwell Automation's retrocabulator. Now basically, the only new principle involved is that instead of power being generated by the relative motion of conductors and fluxes, it's produced by the radial interaction of magneto-resistance and capacitive reactance. The original machine had a base plate of pre-fannulated annuli surmounted by a malleable logarithmic casing in such a way that the two spurting bearings were in a direct line with a panometric fan. The lineup consisted simply of 6 hydrocoptic Marsal vanes, so fitted to the ambifation lunar wave shaft that side pummeling was effectively prevented. The main winding was of the normal lotus oak deltoid type placed in pan-enduring semi-boloid slots of the stator. Every 7th conductor being connected by a non-reversible Tremie pipe to the differential girdle spring on the up end of the gram meters. Moreover, whenever fluorescent score motion is required, it may also be employed in conjunction with a drawn reciprocation Dingle line to reduce sinusoidal depuneration. The retrocabulator has now reached a high level of development and is being successfully used in the operation of Milford trainings. It's available soon wherever Rockwell Automation products are sold.
Ah. How many understood that? Okay, you'll do okay in this class then. How many are scared by that? Only a few? How many think it's real? Yeah, good. But hopefully by the end, I saw more people giggling and giggling. That's my point. That's not real. I just want to know how many times did you have to do that to get it without laughing or messing up? Because gee whiz. I show that for a couple reasons. One, and most importantly, if I start sounding like that to you, will you tell me? Because it doesn't do any good if you watch all that and don't have a clue what the person said. Granted, we're going to have some new terms and some science terms or a new way of thinking of a word that you might not be familiar with, but hopefully I explain it well enough, me in the book. But if not, let me know. I don't want that to happen. This is your class. You came to learn physics, or at least get through this. Let me know. It's funny. What I like is the more towards the end, it gets even wackier and wackier. And sometimes if you knew what some of these terms are, it's like, that is, what the lunar wave module? What the, I don't know. But I enjoyed it. So, demo time. We get to do one. This is one of my favorites. And if we get to fluids later, we'll revisit it. This is an old paint bucket. I put some rubber diaphragm on this side and a hole on this side. And I don't expect you to know the concepts yet, but the gist is you can increase the pressure. If you smush the diaphragm in, the space inside gets smaller. Well, what do all those molecules do? They get smushed together. It increases the pressure. There's a higher pressure inside. Higher pressure likes to flow to lower pressure out here. And so, of course, it escapes the hole. You're like, yeah, I knew that. Well, that's the physics stuff. That's how we're going to break things down. So when I hit it, air comes out. And you can't see the air, but in theory you can feel it. Or somebody with hair, so they can see an effect. Sorry, Catherine. But my favorite part about this is how the air comes out. It doesn't just hit the end here and just kind of spread out. I mean, it can travel pretty far. Can you still feel it? How about in the back? Yeah, I saw your hair. I can't aim very well. But so hopefully, we'll see if this is warmed up. Put some fog inside. Not quite yet. That's all right. This is just one of those fog machines, you know, you buy for Halloween or effects in movies. I just didn't turn it on soon enough. It'll be ready in a minute. See if we have enough so you can see already. When the air comes out, it'll be better than that in a moment. It's still traveling. That's what the air was doing before. And some cool physics behind this. Well, why is it doing that? That's my first thought. So, you know, you can study the stuff. Well, you can understand it even at this point. The air's coming out. The stuff in the middle doesn't get hindered by the trash can, the bucket. But the stuff on the edges does. So there's a little bit of friction. You can think of it as slowing it down. And so the air in the middle rushes out, but the stuff on the end doesn't go as fast. There's like it's rubbing and slowing it down, and so it makes that air kind of turn in around on itself. And that ring, if you could see it, is a spinning donut. Not this way, but it goes on the inside and out, around like this. And this way too. Let's see. Not like this. But it's spinning, and when things spin, they have rotational inertia, new word, which makes them more stable. And they can travel further, like a frisbee or a football. You already know this. If you just kind of take a frisbee and then go for it, but if you spin it, it's more stable and it doesn't wobble and tip, and you can throw it the length of a football field. Same if the football is spiraling really well, or your bicycle. You fall over. But if you're pedaling and the wheels are spinning, it's a little more stable. Let's see where we're at now. And so the air that comes out can carry energy and momentum with it. Yeah, that's good. This ought to be better. There we go. Woohoo. Oh, missed. There we go. How about, you're allergic to it? Or maybe you can go slowly and then knock it off. Okay. I don't know. Can you? Let's see. I'm going to shoot for you. See if we can make it to you. Oh, I saw the hair. That's good. Okay. Bigger is not always better, but in this case, it most definitely is. All right. We'll start on this side first. We can probably get to the back row. With a cameraman. How's it looking, Matt? Do you guys remember the refinery explosion in Woods Cross? It was over a year, maybe two now ago. The key point I want was the explosion sent out a pressure wave. It's air that gets compressed, and it's under higher pressure. Well, that's kind of what's going on here, and it can travel. They wanted to know, yeah.
Is that the same principle that gives a nuclear explosion a mushroom cloud? Like the column?
Yes, yes. It's going up faster in the middle than the outsides, but then it hits, another layer and spreads out. Clouds even. Tornadoes, the pressure in the middle is different than the outside, and it makes it spin because there's a difference in pressure causing things to move. They even saw these smoke rings in the volcanoes from the ash that went up. And they could see it. Oh, we need more gunk, more fog. So with this refinery explosion, they really wanted to emphasize to their viewers how could that wave knock houses like miles away off their foundation or make them shift? That's so cool. And so I pulled these out. Well, actually, they called somebody else up and couldn't get a hold of them. So they defaulted to me. Somebody put them in contact with me. And so they came over, and I pulled this out and showed them that not only can it travel, and there's a difference in pressure, but it carries energy with it, momentum. And that's what we're gonna discuss that. And so it can travel. Whoop. And it carries that energy with it. Imparts that force to the cups and knocks them. Granted, yeah, I know they're styrofoam cups. It's not, but you get the idea. So I felt good. They seemed to like that. But who doesn't like fog rings? So. All right. Turn that off before somebody suffocates. And we got 9 minutes. Let me just dip into chapter 1. Get you guys headed in the right direction. We are going to first cover that's not an exit. But that's all right. That one is. Yes, please start reading chapter 1, 2, 3, 4, 5, 6, 7. We're going to go through those. Not by next time. 1 and 2 is what we're going to focus on. 1, 2, we might get into 3 by the end of the week. We'll see. I don't want you to be spazzed out. These, what do I want to say? It looks like it's a whole chapter. Well, it is a whole chapter. It's not that much depth. The number of concepts covered, in my mind anyway, aren't a lot. We can grasp these together, and we don't need a whole week on a chapter, is my point. You'll see as you start reading them. But they explain it really well, so if you're not getting what I say, it's a way to reiterate it. And he says, well, now I'm going to say it this way. Well, now let me say it this way. Now let me show you an example and say it this way. But it's the same concept. So more so than any time in the rest of the semester, the beginning is might seem to you that we're going kind of fast, only because these chapters relate really well together, and we're going to get through them. My current plan is I'm going to start chapter 1 now. Well, I'm sure I'll finish it next lecture. You'll see, it's short. It's about science. That's what it's titled. The next one is Newton's first law of motion, inertia. And I'll start that one Wednesday. Then they get into linear motion. That's position, velocity, acceleration, things moving. We'll define those and what that means, so that we can then explain in the next chapter Newton's second law with forces, and then Newton's third law, which is still forces. And I mean, that gets us through 5 chapters. It seems like, whoa, 5 chapters. I don't think it'll seem that bad to you. So that's what you can start reading. All I want to say about this first one, it starts off with scientific measurements. And he gives several examples, which I find are good. I'm not going to test you on how Eratosthenes measured the size of the earth, or Aristarchus was able to figure out the distance or the size of the moon. It's useful because I do want you to know how scientists take measurements and what measurement is and why it's important in units. So glean that when you read it. You don't have to be memorizing the history. I'll spare you. When he gets to the scientific method and the scientific attitude and starts talking about fact, law, theory, those I will want you to know about, what those are. What is a fact? What is a law? What is a theory? What's a hypothesis? They're all bold-faced. There's a glossary. This shouldn't be difficult for you. And then it ends with, how does this relate to science? And how does science relate to art and religion? What can we call science and what should we not be calling science? I'm not saying which one's right, which one's wrong. Just what does science claim it is? There's lots of ways at truth. I'm bigger on this than most scientists, I think. There are other means to truth. Science is one of them. And this is what science is. This might be, but scientists don't want you to call it science. And this chapter explains what that is, and we'll discuss that next time. Does that make sense? The next chapter, which I'll very well might start next lecture, is on inertia. So you can start reading chapter 2 as well. We'll know what that is. It's just all about inertia. Do you guys have any questions at all? Concerns? Fog machine?
That's just moisture, right?
Yeah, it's mostly water, and they put a little glycerin in it. It basically heats it up and atomizes it, spits it out into really small droplets. That's what fog is, small water droplets. It just has a little glycerin in it. That's what you might smell. That's all it is.
Right, and the only reason that
Why you can see it?
it just made it so we could
See it, correct. It's condensation. This heated it up, the vapor, so when it comes out here and hits the cold, it condenses and you can see the vapor droplets now. Just like a cloud. So what are you guys going to do? You're working on your book, you're working on your clicker. Register your clicker with WebCT on Blackboard Learning. Check out Webassign for your first test homework thing I showed you. All right.